Thanks for watching our video on downloading historical PowerTrack data. Today we're going to be discussing some key concepts of that process, including the historical job life cycle. And keep in mind, if you have questions about the historical PowerTrack API itself, that we have a separate video that digs into the details of that API from start to finish of generating these data sets. And also, all of our technical documentation is available at support.gnip.com. Later in this video, we're going to download a sample data set using several different methods. And finally, once we have data files downloaded, we will discuss their characteristics and also some of the nuances of how we package the Twitter data in those files. Before we get started, I want to point out that all of our documentation about the historical PowerTrack product is available at support.gnip.com. If you go there and select the APIs link, you'll see the portals to all of these different products, including historical PowerTrack. Another thing worth pointing out, which is extremely relevant to today's video, is that we have a collection of articles, including one that's dedicated to downloading historical PowerTrack files. So after viewing this video today, this is a great go-to resource to learn even more about the process. Here are some key concepts to consider when downloading historical PowerTrack data. The first is that there is a data URL that provides a list of files to download. If you are a subscriber to the historical PowerTrack API, you'll receive this data URL as part of the metadata returned from the API around any completed job. If, on the other hand, you are a one-off customer, perhaps you're doing some research using Twitter data, you will receive a data URL link from your representative at Gnip. Another key concept is that each file covers a 10-minute period. Another key concept is that automation is required, since there may be thousands of files to download, and that really is the purpose of this video. Say you are requesting data from 90 days, keep in mind that there could be well over 12,000 files associated with that data set. Another key concept is that the files are gzip compressed and contain tweets encoded in UTF-8 JSON. And finally, the data is available for downloading for 15 days. This is very important to keep in mind. After those 15 days, the data set is deleted from the server. The process of generating these historical PowerTrack data sets involves several steps. If you are using the API directly, meaning you have a subscription to the API, you will be managing these steps directly with the API. If you are a one-off customer, Gnip will be managing steps 1 through 4 for you on your behalf, and then you'll be tasked with downloading the resulting data. So here's a quick description, a little bit of background of what's going on behind the scenes when generating these data sets. The first step is creating the job, which defines the time period you're searching from. It also includes up to 1,000 filters or rules that are used to pull data into your data set. As part of the process, after a job is created, there is an estimate provided of how many tweets are available, as well as the size of the download and how long the job should take to complete. Based upon that, users have the option to accept or reject the job. Once a job is accepted, there are API calls which let you monitor the progress of that job. And finally, the last step, which we're discussing today, is downloading the data. In order to demonstrate the downloading of data produced by the historical PowerTrack API, I needed an example data set. So I created one from data that was posted during the 2013 Colorado flood. So I looked at a 12-hour period from that event. I used an account here that you see is Gnip-Learning. One thing to note is the UUID, that's the Universally Unique ID. One of these is assigned to every job that's created with the API, and it will be referenced and needed for us to download all the data associated with that job. From the results of the data set, I see that I have 41,921 tweets. These are contained within 72 files. Again, remember these are 10-minute files, so that's 720 minutes total, which equates to 12 hours. And I also see that I have just over 20 megabytes to download. Another very important part of this type of metadata around this completed job is that data URL, which I mentioned previously. This is the URL that will provide the list of files to actually download. This list of files to download provided by the data URL is actually provided in two different formats, and accordingly there are two different endpoints you can hit. First, there's a JSON endpoint, the first one listed here. When you go to that URL, you will receive a JSON array of these files to download, along with some other metadata such as how many files in total were produced. This is a format that if you are writing code in a language like Python or Ruby or Java, you may find this the desirable format of the list to hit. Because it is in JSON, it's quite easy to parse and to iterate through in your code and download each file that it points to. On the other hand, we also provide a CSV endpoint. This, as the name implies, is a simple delimited file with the same type of information, namely the files to download. And some of our examples that we're going to exercise today for downloading will exercise or use this endpoint, namely because we are using things like bash and other utilities like curl, which don't readily parse JSON very easily, and it's simply easier to use a comma delimited type structure. So now we get to the point where we will actually start downloading data. I'm going to be using these type of techniques to download these 72 files associated with this example data set. We're going to start out with using a simple curl command, and then we'll advance to using a bash script, which brings a set of example or advantages with it. And then we'll show some Windows PowerShell utilities that are available. And then we'll quickly discuss the concept of building your own custom code, and for demonstrating that I'll be using a simple Ruby example. So we will use curl as our first demonstration of downloading this data set. This curl command here, it is referenced in our documentation and in that support article we referenced previously. So you're using curl here, you're hitting the endpoint associated with your historical endpoint. It encapsulates your account name and also the job UUID of the job you want to download the data from. And note that it references the results.csv endpoint. So next I'll demonstrate this command. So here you see my version of that curl command. It's referencing my account and my UUID. I authenticate, and here you can start to see the files being downloaded. I have 72 files to download, 20 megs, so this process actually takes a few minutes. Here we are at the end. All the files have been downloaded. I'm going to take a directory listing just to show that the files are here in this local directory. The files are written to the directory where you run the curl command from. So there's my 72 different files. Here I'm going to do a quick word count to confirm I have all my files, and I do. So that's a demo using curl. Now we will use a bash script to download these same files. The bash script that we're going to be working with today is available out at github.com/gnip/support/releases. And the main advantage that this bash script brings to the table is that if your download cycle should get interrupted for any reason, when you restart the script, it has the smarts to know what files it has already downloaded, as opposed to that curl command. If you are curling a large historical set of files and the download gets interrupted halfway through, when you restart that curl command, it just blindly starts back at the beginning and re-downloads everything that you may have already downloaded. So this bash script is most appropriate, or more appropriate, for larger jobs. Certainly if you have more than, say, 100 megabytes of data to get, I would definitely recommend this bash script. So when you download the bash script package from the GitHub site, what you get is a zip file, and when you uncompress it, you get a directory tree such as this. You'll see there's subdirectories for downloads, there's an input directory, a scripts subdirectory, and also the run script itself. A key detail is that in the input folder, that's where you put your results.csv, which is obtained from the CSV endpoint for the data URL that we mentioned previously. So now I'm going to go back into the main root folder of this script and run the run.sh bash script, which brings up this basic menu. You hit D for download, and the downloads start. Again, this is 72 files. This script actually downloads these in a single threaded fashion. Here I've fast forwarded to the end, and I will do a quick directory listing of the downloads folder to confirm I have all my files. So here's that command, and yep, I got 72 files. As I mentioned earlier, the key advantage of this bash script is that it has the smarts to pick up where it left off if there's any interruption to your download cycle. I'm going to simulate that interruption by deleting 24 files from my data set. I'm deleting all the files from hours 20 through 23. And then I'm going to go back, so that leaves me with 48 files. And then I'm going to go back and rerun the script, and you'll notice that it picks up with the first file that's been deleted. So it knows enough not to go re-download the 48 that I didn't touch. And instead it's just going to go get the 24 files I'm missing. And it's about to finish here. So now I have my 72 files. Next, we're going to talk about a set of tools that will be of interest to our Windows users. These are all built with PowerShell. If you go out to gnip.com and see the account gnipdz, you'll find a repository called PowerShell. And that is a set of tools that have been developed around the historical PowerTrack API. Today we're going to show a quick demo of using it to download these files. Note that this PowerShell tool also provides some post-processing capabilities. One thing that it does is it can consolidate all the JSON files into one file, and also it can do some cleanup on the files. As you'll learn later, all of the downloaded files have footers, for example, and this tool can remove those as an option. Here we're going to run the download-historical PowerShell script. When you first run it, it'll ask you for your account name, username, password, and the title of the job you want to download. Then the script will start the process of downloading the files, showing you how many tweets are in the files and how many files to download. Here with the magic of editing, I can jump towards the end of the process where it has already downloaded the 72 files. Now it is decompressing those files. Yet another option for downloading historical PowerTrack data is building an application to manage the downloads. And of course you can do this really in any language that you prefer, be it Java, Python, Ruby, C#, what have you. I'm just going to show a quick example, quick Ruby example. This download that I'm about to kick off is part of a larger project that is a Ruby client built around the entire historical PowerTrack API. You can use it to create jobs and configure your usage of the API. And of course, as part of that, it manages downloads, which I will show you now. So here I am on the command line. I'm about to exercise this Ruby API client. This command line, I'm just referencing a local config file which has all my credentials for accessing the API. but it also references a job description file which has the title and all the other information around this example data set we've been discussing. So when I execute this command, it's going to go out to the API. It's going to get back from the API that this is in fact a completed job, and then that will kick off the download process. So if I go out there, you can see here that it's starting to download the files. So here I am at the end of the download. It took about 70 seconds to grab those 72 files. If I CD into the output folder where this application is configured to write the files, you will see that I have another folder that is in fact the job UUID. If I browse into that and do a directory listing, you'll see all the files. So now that we have the files downloaded, let's talk a little bit about the file names themselves and also some file characteristics. The file names are constructed with the UUID at the start of the file name, and then we have a timestamp, year, month, and day, hour, then minute, and those are in UTC of the beginning time, the beginning minute of that file. So again, these are 10-minute files, so that first file contains the minutes 0 through 9 of the 12th hour, and that second file starts on the 10th minute of that hour and will contain data up and not including 20 minutes after the hour. Finally, that last file, you can see that again this is the beginning timestamp of the last 10 minutes of the time period. I requested data up through midnight UTC on the 13th. So this last file contains data from 2350 up through 2359. Another thing to note, as mentioned before, these files contain JSON data and they are gzip compressed. So when you uncompress these, you will end up with just a file that ends in JSON. And here are some important characteristics of these files. Again, they are gzip compressed. The tweets are encoded in JSON using the UTF-8 character set. Each file will likely contain blank lines, and also each file has a footer with file metadata at the bottom. And this metadata includes the creation time of the file and also how many tweets are included in that file. So these are some important things to keep in mind as you build something that opens these files and parses out the Twitter data. So to wrap things up, we're going to now look at one of these files, actually look inside the file and give you a better picture of how the data is packaged. Here I have two files. I picked one file at random from the 72 that make up my data set. And the lower file here is the compressed version. It's just under 1 megabyte. And then I went ahead and uncompressed that, and it is just over 3 megabytes. So I'm going to open up that file, and here it is in a text editor. A couple things to notice is here we are at the top of the file, and every tweet is listed individually on one per file. And these are not wrapped in any kind of JSON array. Rather, they are, in a sense, atomic tweets listed one after another. As I scroll down here, you're going to notice a couple things. One of importance is occasionally you're going to find blank lines in these files, and that's an artifact of how the files are generated. And so your parsing code, again, needs to be tolerant of these blank lines. And then finally, if I go all the way to the bottom, you're going to find a footer. And that footer starts with a JSON key of info, and again it contains information on when the file was created and how many tweets are in this file. So this tells me I have 887 tweets in this one file, and that's just over 10 minutes of time posting time on Twitter. So again, your parsing code would need to be tolerant of that final header and essentially ignore these footers as you parse these tweets into your system. So that wraps up our video on downloading historical PowerTrack data. I want to remind you, if you have any questions about this product or any of the other products that Gnip provides, please visit our support site at support.gnip.com. Thanks for watching our video on downloading historical PowerTrack data. Be sure to check out our other videos, including one on the historical PowerTrack API, as well as another on our real-time streaming product. And we also have videos on our support site about the Gnip console, about building filters, and others. So let us know if you have any questions, and enjoy your historical Twitter data.